every architect who designed resilient system knows that the queuing system have one big advantage. You decouple a lot of systems in order for scale, but usually queuing systems have one big issue. What are you going to do if your central point, your central communication broker is going down or is slow or whatever, or you have a service degradation?
Hello, everyone. Welcome back to this week's episode of Simplyblock's Cloud Commute podcast. Today, as always, another incredible guest. You know me. I say that every time. I don't have stupid guests. Why would I invite them anyways, right? So another incredible guest, Dominik from HiveMQ, a nice German startup in a slightly different area than we normally have. Most of the time we talk about security, cloud, stuff like that. So there is cloud aspect to that, and I bet Dominik will introduce that. But HiveMQ is mostly like MQTT. So Dominik, maybe just introduce yourself and say a few words about you. Who are you? Where you're from? What you do? And we'll take it from there.
Yeah, thank you, Chris, and thank you for inviting me to this podcast. So my name is Dominik Obermaier. I am CTO and one of the founders of a company called HiveMQ. We're a company, as I mentioned, originated in Germany, but these days we're all around the globe, mainly focusing on the US market and the European market. And we built the we believe the world's best MQTT platform. And this is mainly used by customers, mainly Fortune 500 customers, that are building use cases from connected cars to logistics use cases to big energy grids to industrial IoT. And so we're truly a horizontal platform that's connecting like devices, physical assets with our digital world. And we do that since quite some time. So we started the company in 2012. We're mainly focusing on the automotive space. So if one of our listeners happens to drive in a German car, you are either using HiveMQ while you drive, or you very likely will have HiveMQ being used while the car was manufactured. The same is true for most US cars. And also, since a bit also is true for Asian cars. So we really did a lot of work here. And in the last few years, we focused also mainly on logistics. So if one of the listeners sometimes gets a parcel delivered, also chances are that HiveMQ is being used while the parcel was delivered. And we do a ton of manufacturing, especially in the US these days. And the keywords here are really the unified namespace. And I'm happy to talk about this later, what it means. But yeah, we do a lot of technology, deep technology. We do pretty high scale. And I happen to run all the product and the engineering at this company.
All right. Now, you basically already answered the next question, which was like, what is HiveMQ? But that's fine. That's fine. That's how it works. That's how it rolls. So you mentioned that you're pretty big, or that you basically started with like the automotive industry. And I think, I mean, I know a little bit more about MQTT than probably a lot of the audience. And I think the automotive industry makes a lot of sense for that reason, because you have like a lot of different, well, you could call them devices with a lot of different data points. But maybe you can give a little bit of an introduction, like why is MQTT different from platforms like Kafka or Nuts or stuff like that, stuff that you probably know more commonly when you work on cloud infrastructures.
Yeah, right. So let me quickly introduce MQTT for the listeners who haven't heard of that, or are really trying to understand where does it fit in. So MQTT is a technology; it's a standardized technology, and we tend to think about it that what HTTP is for the human web, MQTT is for the Internet of Things. So it's on its core, it's a communication protocol. It's an open communication protocol. Obviously, all communication protocols should be open in a sense that it's an ISO standard. It's not like a single implementation or single vendor implementation standard. For example, I mean, if you look at Kafka as an example, there seems to be a few companies who are driving that, but it's not an ISO standard. But still you can be compatible, of course, but like the underlying protocol can change
right.
based on this. So this is an ISO standard similar to most communication standards, and it's been around for quite some time. So it's been around since 1999. So which is really, really old in computer age. And it's really interesting. It got a renaissance since 2010. So MQTT was a technology that's based on a publish-subscribe architecture pattern. So many of the listeners who are familiar with enterprise architectures might know about queues and these kind of things to decouple actual communication. And MQTT is also one of these, invented in 1999 for one specific problem: monitoring and acting for oil pipelines. And if you think about it, oil pipeline goes through very remote areas where, especially in 1999, you definitely do not have mobile connectivity, and forget that you have any kind of cable. This means satellite communication was the main way to connect stuff. And even today, satellite communication is extremely expensive. Back then, it was even more expensive. And so the task was for two gentlemen. One of them is called Aaron Nipper, who's now the company called SiriusLink, and the other one is Andy Stanford-Clark, who is working with IBM.
Mm-hmm.
And they invented a communication protocol that saves bandwidth and also gives a almost like quote unquote real-time experience even over very slow networks. And then it was pretty much buried, was not used a lot outside of IBM projects. In 2010, IBM decided to make it open, like just open the standard, promise to don't sue anybody who's implementing the specification. And it's not a real standard, right? So it's not an open standard. And then, to make a long story short, we decided that this is exactly the kind of technology that we believe can power the Internet of Things, because the web technology really don't work for many reasons when it comes to a lot of devices. And I mean, anybody who ran some Java enterprise applications with tens of thousands of users knows the struggle. The struggle is real. And now imagine you have multiple millions of devices connected 24/7 without downtime on a single deployment. It's a really, really tough problem. And we believe MQTT is the solution for this. So we built a company around this. This worked pretty well. And since then it got an ISO standard. I helped also with that together with some other gentlemen at IBM and other companies. And since 2016 or 17, also the big cloud vendors, Microsoft as well as AWS, picked up with their own version, with their own support.
Yeah.
And back then a bit more preliminary. These days they also have a pretty specific, they support the specification. And this is where MQTT really goes from a niche use case technology to a mainstream technology that's being used every day by all of your listeners for pretty much everything that's connected with a physical device to a data center. Chances are that you use MQTT without even knowing, similar to that you don't know that you use HTTP every day.
It's interesting. I didn't know the history of MQTT. I knew it was like super old, but the oil industry, that was news to me. But it makes sense. As you said, even today, MQTT compared to like the other things that I mentioned, like Kafka or stuff, is like a super, super lightweight protocol because it is designed, or that's why it is used in the IS3 industry, in the IoT industry so much, because it is so lightweight. It is low overhead, works on slow connections, and all of that. And it's specifically designed for like scaling out in terms of the numbers of connected devices. And HiveMQ did some magic to make it even broader. I've used MQTT in the past, and I've tried some other tools, and they all have their issues. So
yes, it's really interesting. Like especially the scaling part was. I mean, the MQTT itself has a few problems. Like if you look at the specification itself, like the most obvious one is, and every architect who designed resilient system knows that the queuing system have one big advantage. You decouple a lot of systems in order for scale, but usually queuing systems have one big issue. What are you going to do if your central point, your central communication broker, is going down or is slow or whatever, or you have a service degradation. And so this is, I think, one of the reasons why MQTT really never picked up in the enterprise, let's say, for enterprise customers. Because, I mean, there were open source brokers out there still today. Like many people get started with something called Mosquito. You can, on any Linux machine, you can get it. It's open source. It's awesome. It's small. Roger Light, who was one of the first people actually implementing MQTT outside of IBM, and he's still doing this to this day. So this is great. He did such a great service to the community and to everybody by doing this and maintaining it. It's super small, super lightweight. And there is also other software out there. But what really was one of the problems we discovered is if you want to run this in a mission critical system, like in a connected car platform or in a factory. So, for example, a public case study we have is Mercedes-Benz. Since 2014, they run HiveMQ in their factories. They cannot go down. So you don't have a maintenance window. You cannot update the software easily. And there is one real big problem with MQTT in itself. It has standing TCP connections. Similar to, I mean, most people know their smartphone, they have a push notification service, either Apple or Android and so on. And how these things work is they have an open TCP connection connected to a cloud at all times, which allows the cloud pretty much to push data immediately to your device with a very low latency. So you don't need to poll the data. The problem here is, from a tech standpoint, a standing TCP connection, number one, is very hard to scale to big numbers. And the second thing is what's happening if you update it, if you upgrade things. So this can lead to service disruptions. And so what we built was, we pretty much invented clustering for MQTT. And this was much harder, like in hindsight, much harder than we thought, much harder. But once we got it right, this really helped us immediately get to big customers. As I said, all of the German car makers reached out to us. And since then, we're pretty much in all the connected car platforms for most companies on the globe, because it's a really, really hard problem. And I mean, just to give you a few things on scale, when I say scale, I mean, scale is usually something many companies want to have scale. Most people don't need scale, but with IoT, you actually need scale. One deployment, and this is a single customer, one installation on one cloud. They have, I just looked at the numbers before this conversation. They have more than 20 million devices connected to the platform. This means we talk about 20 million standing TCP connections. They have billions of queued messages at any point of time. And they have 30 million topics. So a topic is similar to, if you look at whatever, Kafka also has a concept of topics. So they have 30 million individual topics. And this is also where you asked about other technologies. MQTT has one thing that's very, very different towards event stream platforms like Kafka or traditional messaging systems like JNS-based systems, or there's RabbitMQ, for example, which is being used a lot in enterprise architectures. These things are very queue-centric, usually. And you don't have millions of queues. This is very unusual. You usually have a few of them. Also with Kafka, you can have a lot of topics, but likely, like, whatever, we have hundreds, thousands or so. Right. But I've never seen a deployment that has whatever tens of millions of Kafka topics. This is not what you want to do usually.
I think usually Kafka will not be your friend anymore.
No, it's like site reliability engineers hate it if you put so many topics into a Kafka. It's not designed for that. Like, Kafka is great. Kafka is an awesome, great big pipe. And this is why it's so great for system integrations, especially on the IT side. You don't need 30, you don't have 30 million of applications you connect. If you have microservice communication you want to do over Kafka, how much do you have? Whatever, 10, 20, 100, 500. But sometimes even more. Some companies are going crazy on microservices. But it's not like you would have tens of thousands of individual applications speaking to each other. I mean, you can, but this is more rare, actually. With MQTT, tens of thousands of devices, easy. 20,000 devices, this is not even scale. We don't even start talking about you. You can do this on a Raspberry Pi in an old generation one. It's like not scale at all. And so think of MQTT as many small thin pipes to individual deployments. And what's really important is, think of an actual use case. Connected car is great for that. If you have 20 million cars running around with actual people in there, and you could imagine a functionality like I can open the car remotely with basically use it as a key. This is a very popular use case these days with cars. And just imagine it works for everybody else, but for you it doesn't work. The problem is this is an actual user that will call your calls and says your software sucks. Your car sucks. Your premium brand is not delivering on the premium promise. This means even if you say, oh, you know what? It's okay if I have whatever 0.1% message loss, or if 1% of all users have high latency. No, it's not, because these are actual users. And so it's a really tough problem to bring it to scale and also have predictable latencies also at a very high scale. This would be probably a deep dive conversation, but it's a very challenging problem. We worked many years on to actually get this right. And now it's the other thing. With MQTT, you are not in control of the client. If you use Kafka or JMS or other things, usually you have end-to-end control because it's not based on open standards. If you look at JMS as an example, the Java messaging service, for people who are not familiar with the term, it's pretty much an API. It doesn't dictate the underlying wire protocol. So if I build a JMS application based on IBM software, chances are that it will not work out of the box with Oracle software. Although I don't need to change my Java implementation if I use it, but the underlying wire protocol, the language changes, and also with Kafka. I mean, Kafka has a Kafka client and a Kafka server. This means if there's more functionality on the Kafka server available in new versions, the Kafka client can also be updated. So it's an end-to-end system. With MQTT, everybody can implement it. There's no control over the client. So the server implementation has a really tough problem being compatible with pretty much every implementation out there you don't even know about. And this is another thing why it's not easy to build an MQTT platform. You would be surprised to see what kind of MQTT clients people are building out there. And there's a lot of behavior that is not allowed to happen, but you will see happening a lot. So
I know. Yeah, I hear you.
Yeah.
It's funny you mentioned Mosquito earlier, and I think Mosquito is like the to-go MQTT thing for Home Assistant and anything like in general, like home automation deployments. I'm actually running it myself. The other thing that you I think you didn't really mention, which I find very interesting about MQTT, it's very what is the term? It's very resilient towards disconnects as well. I mean, if we're talking about connected cars, there's a good chance, at least if you're in Germany, that you actually lose connection to mobile networks for a bit and then you just reconnect. For Kafka, that would be a disaster. It really hates that. For MQTT, you reconnect and you keep pushing.
Yeah, you actually make a great point here, and the ultimate test is if people, especially here in Europe or in Germany in particular, go to the German train system and try to move there. You will challenge every application, and usually MQTT connectivity works much better than most others because it's so slim and lightweight. As long as you have a TCP connection that is not aborted, you can still use it, and it's very, very efficient here. But you mentioned a great feature of MQTT. It was designed for programmers they don't need to care about am I connected or not. You can resume with their application if you have a connection up because it queues locally, it queues on the client on the server, and it actually resumes. So the only thing you do is similar to other messaging protocols. You pretty much tell the underlying transport, oh, I want to have fire and forget because I really don't care about the data. Or I want to have I deliver it at least once, but I don't care if it's duplicate. Or make sure, dear protocol, make sure that the piece of data arrives exactly once. And I think what I also didn't mention is everything is in order. So the protocol makes sure that the data is in order. It would be, for many use cases, a disaster. Again, let's assume I would lock and unlock my car. If this messages would arrive out of order, actually like unlock, lock, then I would lock it first and then unlock it and then move away from my car. This would be pretty bad. And this might sound like trivial use cases to you, and people sometimes say, yeah, what you should do is otherwise and so on. Yes, this is true, but the guarantees the communication protocol gives you is extremely important. And I think the last one, what I want to mention, what many people don't really appreciate a lot, is if you go with a standard like MQTT, you can change your implementation on the server at any point of time. So as an example, if you are building, again, a car and you have for 10 to 15 years, you have a very hard time actually changing the software. So the interface, almost the API, it must be compatible. So in our case, if we don't do our job properly and then one of our customers decides that they are discontinuing the work with us and replacing us with some other protocol compliant software, they can do that because there's no login. And this is very different to most messaging systems. So, I mean, I remember when I started my career, I was working with other software, queuing software. They were selling you actual client implementations and so on. So that the business model really was different. So you always had a lock-in effect. And MQTT is one of the few communication protocols that tries actually to be standards compliant and not reliant on the vendor. And I think this is great. The reason why the internet is great, the reason why we have all this innovation is because we built that communication network as humans. We call it internet. It's based on open standards, and they won. And this is also, I think, why MQTT gets so much popularity. And we now see, by the way, what we see 2010 to 2020 in the IoT age, I would say. We now see basically switching towards industrial IoT inside factories, and all of this legacy technology, all of these legacy protocols. Vendors will sell you gladly their client implementations for a lot of old school proprietary protocols just to connect things. And people are really get fed up by that. Why would you do that in 2024? So MQTT is now getting a lot into factories. We do a lot of work here. If you look at Fortune 500 companies from pharma to automotive to package sorting centers in logistics, discrete manufacturing and process manufacturing, all of them are looking to MQTT-based architectures. And the promise they are building is what they call unified namespace. It allows you finally to connect all of your applications and physical assets together in a way that you can exchange data without, number one, paying a lot of money and without actually waiting multiple months or even years to get some data flows changed. And this is something that's really exciting. And MQTT now goes full circle from oil pipelines, satellites, to cars and connected toothbrushes and whatnot, to actual factories, and finally again back to oil pipelines. So things go full circle in this 20 years.
We already crossed the 20-minute mark. That was like super fast. There's two questions I want to ask you still. Sorry for the audience. It's gonna be a longer episode again. Like I think I've never hit the 20-minute mark. So first of all, you can install it on-prem. I think that was always an option, but there's also HiveMQ Cloud. And we're a cloud podcast, or also Kubernetes podcast. Does that run on Kubernetes?
So HiveMQ, we love Kubernetes. On premises, a lot of our customers are running it on Kubernetes. If you look at modern connected car platforms, a lot of them are using Kubernetes. HiveMQ Cloud itself we have a lot of Kubernetes expertise. I cannot share too much about this, but Kubernetes is a first-class citizen for everything we do. We have a Kubernetes operator that's, I would say, pretty sophisticated. And what we do is we dog food everything ourselves. So also our own cloud runs on the same technology that we sell to our customers. And what companies are building is this kind of edge to cloud central nervous system. You really want to connect the data flows, and you can do that with HiveMQ very easily. And by the way, for the listeners who say, you know what, this MQTT thing looks great, but I don't want to install stuff at home, we have something called HiveMQ Cloud Serverless. It's completely free, no credit card required. It's really like, this is what we give back to the community that gave so much to us, and it really helped us also grow as a company. This is our gift to the community. It's free up to 100 devices. You can connect whatever you want. It will be free forever, and you will even get some integrations to other services. I believe Kafka is available and others. So you can just hook it up, use it, have an endpoint in the cloud that's secure, and doesn't cost you a dime. And it's probably the easiest way to get started with MQTT.
Oh, that's cool. I didn't know about that. It was not around when I looked last at HiveMQ. Good to know. All right. Final question. Final question. If that is a thing. What do you think? It's basically always the last question. Like, what do you think is like the next big thing in terms of cloud? For you, probably like message-based communication, database, AI. I don't know.
Yeah. So I try to keep it brief, especially the AI thing and so on is interesting. But I won't go into that. I won't go into LLMs and other things. And my opinion on this. What's really big is the whole unified namespace topic for me. I'm really excited that companies are thinking of making data available to the users that actually can benefit from the data, outside of data lakes and so on. For the last, forever, since I'm working in the industry, everybody wanted to move the data to the cloud.
Mm-hmm.
And you have data lakes and all of that, and it's great and it's awesome. But actually making the data available to the people on the shop floors working every day, and not only to the data analyst, is something that's really, really interesting for me. And so it's about really building this kind of central nervous system. I really care about this. I do see this as a really big trend, even outside
Mm-hmm.
of manufacturing. We see it in the energy and so on. We don't see it in, let's say, the traditional cloud technology business so much.
Not yet.
I hear what the
maybe.
trends are. I think there's other people who can talk better about it. I really care about the customer use cases and how the industries are transforming. I can just tell you, I'm so excited if I look at how, for example, in the energy grids, how sustainable energy grids are being built these days to get us away from, let's say, these unsustainable way of doing stuff on our Earth. This excites me when I see customers we have are deploying billions in infrastructure just to get away from coal and other things, sustainable energy, and it's humbling, very frankly, to see that HiveMQ is being used pretty much managing all those energy grids and all of that. So yeah, it's not an IT trend, but I'm very, very thankful that we see with our customers trends that we make our world more livable place.
I think that is a perfect sentence to end the show. That is brilliant. We all want to do something better for the environment. I think we know our industry creates a lot of CO2 footprint, and there's ways to optimize that. And I think that is a big trend that needs to go onwards. All right, cool. Yeah, as I said, we're way over time already. That doesn't matter though. As long as people are listening in, it's all fine. Thank you, Dominik. Thank you for being here. That was a delightful chat. And for the audience, you know where you find us. Same place, same time next week. I hope you listen again. Thank you very much. Thank you, Dominik.
Thank you, Chris.